All right, here we are for software testing and office automation, part 2. And of course, before we do any testing, we need an application to test. So I've invented this little imaginary login window here. It's got some static text on it. It's got some input fields. It's got a push button. Pretty simple, pretty standard. Just the kind of thing that you'd see when you launch most any application today. Now, right off the bat, before we start doing any testing, the developers and the software testers, they have limitations imposed on the platform, the hardware platform that they're going to use. The VT100 here was character-based. It had 80 characters and 24 rows. The Radio Shack computer was character-based, at least the Model 1 was. It had 64 characters and 16 rows. Now, the 3270 PC had a graphics character generator in it, but when it was connected to the mainframe doing COBOL work and stuff like that, it had selectable columns and rows. Depending on how you set it up, there'd be different amounts of text on the monitor that you were looking at. And today's smartphones are graphics based. They're pretty amazing. You can watch movies on them if you want. You can add numbers together if you want. And they're all pixel based. And each phone's a little different. The one I picked to show here is 1080 by 1920 deep. So that's one thing you have to consider when you start testing. Now, like I said, depending on the platform, which is the hardware and software of your application, there's different things. There's windows, there's some containers, and there's objects all over the place. So here's the simple little login window. There's some things that are invisible that you can't really see. One of them is a frame here. It's pretty hard to know it's there unless you're the coder or you have software, testing software that will tell you that it's there. We have some static text. We have some edit boxes. And some of these edit boxes can have labels on them. And sometimes it's static text and then edit boxes or input boxes. And we have a push button here. So that's the simple screen we're going to go over today. You'll find out that even though we're just going to go over one screen, things can get pretty complicated. One thing you have to know is that when people write software, most everything has to have a unique name. Now, in object-oriented programming, which we'll get into later, sometimes the methods can have the same name, but the software knows which one you're calling. Suppose you're making an adding machine and you wanted to have a method that added numbers together, but some of the numbers were integers, some were floats, some were double precision. You might have 3 or 4 or 5 different kinds of methods called add, but depending on what you passed it, the software would know which one you meant. But in COBOL, everything has to have a unique name. Most of the older programs had to have unique names. So here I named a login window and static text at the top, the edit box for the username, the password, and the login button. So just with those simple things, you can see over here that there's a lot of different tests. Does the window appear? Does the static text appear? Some programmers will find spelling errors that the coders make. And sometimes the coders will find mistakes that the testers make when they write a trouble ticket, which we'll get into later also. Make sure that the edit box appears, it accepts data, and the data is correct. If it has to have special characters in it, or it can only be so long, it checks for that. It's not blank if it has to be there, and it's valid, like I said. You have one for the login, the password. It appears, it accepts data, it's not blank, and it's valid. Most passwords you have to have upper or lower case, some special characters. It has to be so long so people can't guess it. And the push button appears when you press it. It checks the data on the screen, making sure the username and the password are correct. It knows who you are. If something's wrong, it throws different kinds of errors, like username left blank, password doesn't match, blah, blah, blah. If everything works, it advances to the next page, which we're going to do. Like I said, the windows, containers, and objects usually have unique names, except unless you're using like Java programming, and it has different methods to handle different things, but the methods are all called the same thing. But here we go. We have all the unique names here. We'll pretend that's what we need. Now, most software testing applications, they have some kind of a spy. There he is right there. And when you use the spy and you use the cursor to point at something, like the login button, the spy says, oh, it's a push button, and it's named SSS login button. So that's a handy way to find things on the screen. Like I said, if the frames are invisible, sometimes the spy can't even find them easily, so you have to be careful. And some software testing applications have a record and playback feature. Right here, I just set it up to be a record feature, but what it does is you bring the application up, you type some stuff in, you push some buttons, it records all that action in the database, and most of those software testing applications have a robot that can rerun your actions. So if you bring the screen up again and you run the robot, it puts the same username in you typed, the same password, and presses the button. So that's a handy little contraption, and it also helps you find sometimes some of those invisible things on the screen that you're interested in finding. And some software testing applications create a map while you're going through the screens. It creates a map, and it may use different names than the name the software coder used, because everything has to be unique on this screen for the software, the testing software to work. It might add the name that the programmer gave it. It might put X and Y coordinates there if it's really getting confused. It might know it's a special kind of object, like an text edit field or a button, and it makes a map. And you can use that map in these software testing applications to write code. The problem with that is if the developer changes the name of something on the screen or adds something that confuses it, this map gets messed up. And when you mess up the map, strange things happen. So here we are. There are basically two types of, I don't even know what happened there, but I'm not going to go back and find out. There's basically two types of testing. There's black box testing and white box testing, or crystal or glass testing, whatever you want to call it. Black box testing, the coding inside is a mystery. They just give you an input sheet and they give you outputs that are supposed to happen magically. So in this example, I'm saying if there's just a blue input comes out. It's not obvious, that's what I'm saying, but I'm telling you that. If you have only a green input comes out. And if you have simultaneously entered a blue and a green input, then this orange one comes out. Now in the white box testing, you can see that there's code in here. You can see that you can kind of follow this around, and you know if that happens, that happens, and if that happens, that happens. And if I was more clever, I'd have both of them coming in at once, but I like to keep these things down to 12 slides. So You have to take my word for it. If they both come in at the same time, they create this orange output. But you'll see there's some code in here that's not getting used. There's nothing there. There's no error codes. There's no messages. It's dead code. And that's something that has to be addressed. And that's what I talk about over here, this dead code. You can see that here's where I explain what I've been talking about. If only blue comes in, blue goes out. If only green comes in, only green goes out. And if they both come in, then this comes out and the missing code is here. Now there was a company, it's still there. I shouldn't say was, McCabe. You can look it up on the internet. They used to have a thing called Battle Map back in the days in COBOL and straightforward programming. You used to draw a map. It would draw a map, and it would show you these different paths that the different tests would go down through, and it would show you what you had to set up as far as data to make it go down the paths. And as it went down, as your testing proceeded automatically or manually, with this data it suggested, it would light up these boxes and lines green, and the ones that were red, you either didn't go down or you didn't. If it was yellow, it meant you didn't go down all the possible paths. And one thing about this is it led to path testing, which kind of helps verify that your code is actually working the way it's supposed to work. So here's the basic procedural COBOL basic. It's easy to understand. It just starts at the top and it goes down and it ends at the bottom. There's a couple commands where you can jump from one place to another, either jump down or jump back with go-to statements, but even that's pretty simple because everything had a line number and it was easy to figure out what was going on. And then we got into object-oriented programming. Java is a good example. This part here shows you the same part as these first two lines up here. You can see it's more complicated and you have to know a little bit more. It's harder to write and it's more complex. It led to extreme programming, and that led to writing tests first and then writing the functions so that the tests would pass. And it supports unit testing and integration testing and acceptance testing. And you could do the same unit testing and integration acceptance testing with procedural code. But it's more important when you use object-oriented programming techniques because it's not this code gets really convoluted. It's hard to understand even for the programmers. I mean, if you're writing a big system over a year or two, which most big system takes a long time to write, you can go back and try to figure out what you did. And the same thing goes with writing automated test scripts. It's good to put a lot of comments in. We're going to go over all this stuff in the future, but all you need to know now is that object-oriented programming is harder to write and it's harder to test. But we're going to get through this. So I hope everything is working out. I'm trying to keep these down to 12 slides. We'll see what happens, trying to keep them under 15 minutes. This is the second one. Enjoy.